Everybody, in this video we're going to talk about molecular and empirical formula, and this is definitely a part of the percent composition, and actually this is the fun part, or what I consider the fun part. And so this process is fairly prescriptive, meaning that there's just certain steps. You follow the steps, you do them correctly, and everything will turn out right. Okay, and what we're going to do is we're going to take the percents, like percent composition. If we have 81.71% carbon and 18 point whatever percent hydrogen, can we come up with a formula? And so that's the way that it actually works most of the time in chemistry, in like real chemistry when you're out in the real world. So that's why I like this, and it's also, I like that it's kind of follow the steps. That always is good. And so these are the steps we're going to follow. We're going to assume 100 grams. Okay, we're going to divide by the molar mass of the element, and then we're going to take all of those and we're going to divide all of them by the smallest. And then this step, the fiddle step, we're going to mess around with the values to make sure that they are whole numbers. Okay, and that's what we have here, the lowest whole number ratio. Now, a molecular formula, instead of giving you the lowest whole number ratio, the molecular formula can give you the total number of atoms in the molecule. And so, for example, a very common one of these is hydrogen peroxide. Hydrogen peroxide, you may or may not know, is H2O2. But notice that it's 2 to 2. This is a molecular formula because we know that there are 2 hydrogens and 2 oxygens in the compound. The empirical formula would be HO. Okay? The only thing that we need beyond the empirical formula to determine the molecular formula is the molar mass. Okay? Somehow that has to be given to you in order to determine this. Okay? So let's do a sample problem. Okay? And here we have hydrazine, and it is composed of whatever. Okay? You may want to even try this on your own, following the steps, and pause and see if you can get it. If not, here we go. Okay, so we're going to assume 100 grams. By assuming 100 grams, what is 87.42% of 100? Okay, so here, I'll write that here. Assume 100 grams. And so by doing that, and I'm not even going to do the math, I'm just going to do 87.42 grams of nitrogen and 12.58 grams of hydrogen. Okay, now that doesn't give us much, but that at least starts us down the path, because the formula, a molecular formula or empirical formula, gives us the ratio to the number of moles of atoms, or the number of atoms in the molecule. So we're at grams, so if we're trying to get a mole ratio, we have to convert to moles. So this is where we divide by, or convert to, molar mass. And in order to convert, not convert to molar mass, convert using molar mass, we convert to moles. So we're going to go grams, moles. So 1 mole for nitrogen is 14.007 grams. And we do this, we go 87.42 divided by, helps if I turn it on, 87.42 divided by 14.007. Okay, so we get 6.24 moles. Okay, so this was the convert to moles step. Okay, I'm going to do the same thing for hydrogen. Okay, I want to go from grams to moles. So if I want to do that, for every 1 mole, hydrogen is 1.00794 grams. So we're going to do 12.58 divided by 1.00794, and that gives us an answer of just about 12. So 12.48 moles. Okay, and now of these two things, I'm going to put nitrogen and hydrogen here. We pick the smallest. Which one is the smallest? This one. Okay, so we're going to divide both numbers of moles by the smallest, and that's going to give us the ratio. Moles N, that's going to be 1, and there should always be a value that's 1 from this step, because the smallest divided by itself is always going to be 1. And then 6.24 moles of N, that gives you a ratio now that you have 1 mole of N for every 2 moles of H. And notice these are both whole numbers, so we don't have to fiddle with it. Okay? So the empirical formula is NH2. But that's not the molecular formula. The molecular formula now asks us to take the molar mass and determine the molecular formula based on this empirical formula. In order to do that, this is the process that we're going to do. What is the mass, the molar mass of NH2? Okay, I'm going to round at this point, but this molar mass is 14 plus 2. Nitrogen weighs 14, hydrogen weighs 2, and so the mass here is 16. That's the molar mass. What is the molar mass of the compound? The molar mass of the compound is 32, or twice that. And if you're unsure, you can go 32 divided by 16, and that's going to equal 2. So that tells us that the molecular formula is twice the empirical formula. So it's 2 times NH2, so that means that it's N2H4. Okay, so that just tells us the multiplication that we need to do in order to get there. So now we want to do the same thing for this compound eugenol. Eugenol is in cloves. It's actually the yummy oil that smells really good that's in cloves. Okay, and this gives us kind of the next thing, is that here we have the rest being oxygen. And so we may not be given the percentages of all of them, but we know that they have to add up to 100%. Okay, and so that's what we do. So for carbon, we have, and again, assume 100 grams, because 73.14% of 100 is 73.14 grams. We can assume any number that we want. Okay, we could assume any number that we want. But we choose 100 because it makes this first step easy. We could choose 83,192. It's going to work out the same way, but we choose 100 to make it easier. Okay, so this is going to be 73.14 grams. So there's our assume 100 grams. And then hydrogen is 7.37 grams. And then oxygen, the rest is oxygen, so we need to figure out how much is oxygen. So 73.14 plus 7.37. Okay, now we do 100 minus answer. So now we know that we have 19.49 grams of oxygen. So now we have to convert this to moles. So we do grams per mole. I would suggest you always use the number all the way out, but I'm going to just use 12. So 73.14 divided by 12. Okay, so this is equal to 6.095. And then this, we X-line, we convert to moles. This is grams on the bottom, moles on top for every 1 mole. Hydrogen weighs 1. And so this is 7.37. And then we do the same thing for oxygen. And so we do 19.49 divided by 16. And so we get that equal to 1.22. The next step is to divide by the smallest of these values. So that's what we're going to do. That's this one. So that's 1.22. So that one equals 1. Divide by 1.22. So 7.37 divided by 1.22. And this equals 6, and then 6.9095 divided by 1.22, okay, is equal to about 5. And so notice on the calculator you get that number you get like 4.99590. So the idea here is that that's close enough to 5 to do this. And even that one where it's 6.04, that one is close enough as well. Okay, so this is how you determine the empirical and molecular. Oh, wait. I'm jumping the gun here. So this is going to be C5H6O. Okay, but now we need the molecular formula. So we find the mass of this, so 5 times 12 plus 6 times 16 plus, not 6 times 16, let me write this. So it's 5 times 12 for carbon. Hydrogen is 6 times 1. And oxygen is, there's one of them times 16. So let's clear this. So 5 times 12 plus 6 times 1. I'll put it in there. Plus 1 times 16. Okay, and that's 82. This adds up to 82. The overall molar mass is this. Okay, so we take 164.2 divided by 82, and we get that this has to be twice in order for it to equal that. So the molecular formula is C10H12O2. Okay? And so that is how you figure out empirical and molecular formula. Okay, I hope that clears it up.